In this video, I'm discussing the Vintage Computing Christmas Challenge 2024 that is put on by Logiker. I'm going to be covering my submission, how I arrived at my submission. The goal of this year's competition is to generate that box, all the characters that are white in here, and the little dude right here with the backslash and the forward slash, and do it on any computer system in any programming language that you feel like using. You could use anything, and there was even an entry that was done with a vintage calculator. On this video, I'm just going to be covering the basic entries. There were submissions for assembly language, and there were submissions for many other programming languages, and there were wild submissions, which means you could do any kind of a variation of this, and they were really beautiful. And you should check out the video that Logiker put out for all of the results of this competition on his channel, and I will have the link in the description. And this year Logiker even was giving away a couple of prizes, which were some retro computer books. All right, I'm going to quickly go through how I built my submission, and that's these first 11 here. And then I'm going to go and I'm going to look at a few of the top submissions that I was checking out. And there were a bunch more that I just don't have time to cover here. So when I first started with the competition, I was just trying to figure out a way that I could create a program that would not only just draw the lines going across, but have the plus signs or something at the beginning, middle, and end of each line. And that's what I started off with this. The reason why I have this kind of weird division in here in this integer, I was trying to figure out on the fly how to do a mod command, because in this Commodore Basic that we're using here, it doesn't have a mod command, and that's how I was working around. There's probably a better way to do that. And then as I progressed, I went on to built it up to this version, expanding upon that first version. And I made the mistake that I thought that we needed to clear the screen, and it needed to be shifted over, some about 10 characters over, and it needed to be shifted down. But then I noticed when I was watching the submission videos that Logiker was showing on his presentation that nobody was doing that, or very few people were actually doing that. So this is how I came up with that. I just kind of expanded upon that first one. This is just a for loop that loops through and kind of calculates that. The problem with this version and the other version is that once you build it out, and I don't even have the bow at the top, it's already at 217 bytes. So I thought maybe I could optimize it a little bit, and we'll go off to this version. I said, I can change the clear screen command up at the top and save a few bytes, and do a few other little minor optimizations, and push it down and over, and we got to this version at 187 bytes, still way bigger than what I was even looking for. I knew that was nowhere in the ballpark. So then I went ahead and tried to optimize that version a little more, but putting everything on as few lines as possible, and I ended up coming up with this final, I believe, the final version of this algorithm, if you will, is at 157 bytes, which I didn't submit. I was determined to find a better solution than this. I was like, well, that's the best I could do. This might be better algorithm for assembly language, but I decided in this competition I wasn't going to do an assembly language version. So that bring me to this sixth version. I said, well, let me just do a more of a straightforward approach where we clear the screen, draw the characters going across, and then maybe build it out, do a loop that kind of does the middle characters. And I started with this just to get going, and then kind of led me to this version, which is 181 bytes, which is still more than what I was looking for, but I knew there was a lot of room for optimization here. And I know there's not supposed to be a 0 right here, but I think I was kind of experimenting around. I think it needs to be changed to a O. And so that brought me to the next version, version 8 here. And I started trying to optimize the algorithm a little bit. It's basically the same thing, except I went ahead and I completed it, moved it where I wanted it to be, I pushed it out 10 characters, 5 characters down, have the correct characters in the bow. I'm still clearing the screen. I'm pushing down 5 characters. I knew there was more optimization to be done even with this at 131 bytes, which brought me to the next version. Went ahead and I realized I didn't need that clear screen. This one here, I don't clear the screen at the beginning. Instead, I decided I'd clear it when I'm doing the print command. You could do a clear, and then instead of having down, 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 I put down times 5, but it didn't really save me any bytes. I was hoping for some savings. And it is a little bit more optimized. And this was after a few days of working on it, got it down to 113. And you can see here, and it's just a loop, and I have I'm doing this space command, print space 29. Through doing this, I realized when I was trying to optimize, if you get everything on one line, it does require fewer bytes. And so I was trying to stick with that one line approach. And then I realized, if we're looking at between version 9 and version 10, I realized that when you're doing the print command, you don't need these semicolons in between the items you're printing. I thought you needed to kind of append them with a semicolon in all these areas. But so in the version 10 here, I just eliminated all those, and that got me down to 104 bytes, and it ran fine. And it runs quick, right? It was just a quickly running program. Even with this, I knew there was a little bit more that I could optimize. I decided to get rid of these commands, some of these commands, the cleared and then the down 5. I was like, oh, I don't really need that. If I just increase the spaces here on this part, like if I make that like 200 something, then that's like the equivalent of going down 4 or 5 lines. So I went ahead, and that's the one I ended up submitting, is this version here where I eliminated that part, and that brought my program down to 97 bytes. And I'm going by the size here listed in CBM Program Studio. Tells me this is my program size. I think it's a little off from what other people are saying that their program size is, so I'm a little confused by that. I'm not really sure. Maybe I'm using the wrong number here. So this one was 97 bytes, and that's the one I ended up submitting to the competition. Now, I love doing these competitions because I always learn new things or figure out different ideas and sometimes techniques that I wasn't thinking of, and maybe even algorithms too. And so I'm just going to take a quick look here going down the line. And this is one submitted by Club 77. And if you look at it, it's got a little algorithm. It's a 2-line approach. And when you run it, it's at 85 bytes, and it sort of runs slowly. The rest of the ones that use the algorithm take a lot of time to run. And so it's interesting. It's similar. It has some concepts that I was using, but definitely it's a little more complicated to understand. And so then Logiker himself submitted one, had a submission, and let's take a look at that. And let's run it. It's a 1-liner. And according to CBM Program Studio, it is 78 bytes. And I would hazard a guess it's roughly the same speed, maybe a little quicker than the last one. And this was the first one that I remember. I was looking at it, and it's using a sign function. So it's doing a mid-string, and it's trying to calculate which character to print, the dash plus space or exclamation. Honestly, I don't really understand how that's working, but I thought it was interesting. Like, wow. And then it's going from 2 to 20, and then another loop from 0 to 18. That is Logiker's. And he said he wasn't really in the competition. He just wanted to submit his version. The next one I was just going to look at was by Adam M. Let's run it. Seems a little more simplified, and it runs at 76 bytes. And look how quick it runs. And you'll notice even Logiker's and this one, they're not spaced over 10, and they're not spaced down. Yeah, if we look at the way Logiker's was running, we'll kind of warp that. Even warped, it goes slow. But you notice, yeah, even his is up at the top. They didn't clear the screen. They didn't do I was doing a command also in my submission at the end of the program. I was doing a command to make the program freeze. So when it ran, it didn't do the ready prompt right afterwards. And I think I might have been the only one that did that. I don't know, but I just was trying to display what was on the screen, just like at the beginning of the competition, what he said he wanted the screen to look like. I didn't realize we could have it all the way to the left and all the way to the top, and we didn't have to freeze the screen. I could have saved 3 bytes by eliminating that right there. But going back to Adam's, Adam's is fairly simplistic as well. It's just a one for loop here, and it's like, oh, wow, that's interesting. Okay, and he has an if statement. I get what he's trying to do here. He didn't want to print this line more than the 3 times. And then Serato, I believe, is the smallest program, bytes-wise. And let's run his, according to CBM Program Studio, it runs in 75 bytes. Now, I said smallest. There are other versions of the Commodore Basic. There was a 128 version that had fewer bytes. There was a PET version that had, believe had fewer bytes. There were other computer versions that had fewer bytes, but this is the smallest one that I remember seeing for the Commodore 64 as well as in BASIC. So there was a lot of assembly language ones that were smaller than all of these. But you'll notice his also uses the sign command, and it uses some complicated maths here. I was like, oh wow, -9 to 9, and then for y equal, and then for x equals -9 to 9. And I was thinking about doing something like this, but it never really occurred to me to try doing a mid string to pick between the characters and then use some sort of sine wave thing to figure out that. I would imagine it's going from the top of the sine wave to the bottom in order to pick some of those values. And so having seen all that, I realized one of the things on Logikers, I noticed here he's using this print comma, and I was like, and then also on Adams also has a comma there. And that was when I realized that when you do this print comma thing, let me show. So if you go new, print comma comma, it does like the equivalent of a print space 20 or 10, you know, like, yeah, so it's 10. So it's printing 10 characters for each comma. And that was something that I learned from looking at other people's programs, like, oh, that is a good technique. Because of that, and the whole idea of not having to space this out over 10 and down 5, and not having to worry about the ready prompt after it finishes running, I went ahead and I revised my submission. I of course didn't resubmit it. The competition's over, but I was like, hey, after the fact for this video, and I stripped out the print space commands and put in these commas to do 10 spaces. Of course, if you only need to move over 8, you have to go back 2 with left. And then this M0 thing, that's the bow, and then some more spaces, and a few spaces here with a comma and a comma over here. Let's show you what that did for my program here, as I am very close to concluding this video. Apologies for taking so long. And you'll see there it is now with it not spaced over and not shifting it down, not worrying about the end. And I got it shrunk down to 82 bytes. So this kind of shows you it's competitive. It's not as good as the top submissions, but there's probably some room for some further optimization. But this was as much as I could squeeze out of it, and from the techniques that I learned from the other submissions. Anyhow, this is one of those things I love to do, is following when I'm working on the Christmas challenges. It's fun to do, is try to learn how to make your program in as few bytes as possible without making it blow up. So anyhow, that was my video. I hope you enjoyed and learned something from it. Thanks for watching.